Hello, guys. My name is Usman Jallo. I am a software architect at Jana.io. Jana.io is a lab for developing cloud native application solutions. So basically, what I want to do here is a series of videos where we introduce Jana.io as a project to the public. So we're going to be introducing what I call the Jana Software Accelerator Project. Basically, this is a journey into the business of software engineering, data science, machine learning, and blockchain. So we're going to be using the best practices in industry and research. This series would include basically videos, blogs, and other social media posts that involve Twitter to Facebook, Instagram, TikTok, basically anywhere people are streaming. We want to be showcasing the best in software engineering, and we want to focus on data science, machine learning, and blockchain. Uh, but in order to go into this journey, though, basically we need two vehicles to take us to basically facilitate our journey. Vehicle one, the first vehicle is we are building what I call the Gen Accelerator platform. So think about the accelerator as a place where we build apps real quick because we have already infrastructure that we're building to support building applications. Um, But the accelerator here, the special thing about the accelerator here is our accelerator is an app, right? So we have an accelerator for building software apps, but the accelerator itself is a software app, right? So the idea is charity starts at home. So the idea is if you're going to build all these fancy apps, you yourself need to be a fancy app. So fancy in this case is basically machine learning, blockchain, and some fancy data science to support the machine learning, right? Uh, Vehicle number two that we need for this journey is the Jana operator. So our main app is the accelerator that we use to build other apps. But because this accelerator is a cloud native application, we have to actually deploy this accelerator app in a Kubernetes cluster in a cloud. So that is the idea is we should be capable to deploy our operators, our applications in a public cloud or private cloud. So private cloud tools such as OpenShift, Rancher, public cloud involve things like Google GKEs, Kubernetes clusters on Google Cloud, Amazon, AWS, Fargate, to like Azure Kubernetes. So the idea is if you're running Kubernetes on any of the major public clouds from Amazon to AWS to Google, or if you're running a private cloud using tools like OpenShift or tools like Rancher, or if you're just running a local cloud on your laptop or desktop using tools like Kind, Micro Kubernetes, you should be able to deploy the Jana infrastructure in this cloud. But the way you deploy the Jana infrastructure is to use the Jana operator, right? So this video is basically to introduce the Jana operator to the public. So what I want to do today is do a quick demo of how we deploy Jana using the Jana operator to a local Kubernetes environment here on my laptop. Um, so part of the deployment is Jana needs a tool called Kubeflow. What Kubeflow allows us to do, Kubeflow basically gives us a backbone to do end-to-end machine learning pipelines, right? So let's say we have data that we're harvesting from infrastructure. That data has to be crunched and converted into a format that we can model using TensorFlow, and then those models then become basically our machine learning features, right? So the idea is we part of deploying Jana, first we deploy the Kubeflow infrastructure. So the end product will look like this. So this is what Jana looks like after we've deployed Kubeflow, processes are up and running. So what we're going to do, we're going to start an end-to-end deployment using a tool called Molecule. So let's take a look at Molecule here. So what Molecule lets you do, Molecule helps you create end-to-end scenarios. So from start to finish, right? So the idea is you have this matrix here where you start, you do a cleanup. So whatever that was previously deployed on your infrastructure, you will clean it up and then you will destroy everything. Then you will create brand new clusters to deploy your operator and your application. And then you prepare those clusters for anything like user account, basically service accounts, networking, storage that you need to add to that cluster to prepare it for your operator and the application that the operator will be deploying. And then what they call converge here is basically where you actually do deploy your application and whatever customizations you need to make. And then what it lets you do after your deployment, you can do verification to test that things are where they're supposed to be. For example, you can verify that your services are up and running and everybody's happy. And that way you can basically say, yes, you did deploy your application, right? But from a high level perspective, here is a blueprint of the Jana operator. So we have commands that we use to basically boot up Jana. And once Jana is up and running, there's network configurations we'll have to do to basically set up our network environment. Once we have networking into a space or place we're comfortable with, we'll then start to do all the configurations we need to do to set up our storage infrastructure. So I do want to set up a CSI infrastructure. Uh, that way we can have persistent volumes that our applications can use to store data over time. And then once we have storage up and running in a place or a space that we like, we would then start to set up our compute infrastructure. So specifically in our case, uh, this will be where the gut of the machine learning happens. So here we will be using TensorFlow, Jupyter Notebook. Uh, we will be integrating with Facebook for basically social media posting, because ideally what we would like to do is every task that we accomplish at Jana, we'll then create social media posting for it. We'll then create blogs about our day-to-day work. So Jana would have to be integrated with social media for basically advertising what we're doing day to day. But then we as part of that whole infrastructure, we want a smart way to have user interfaces for Jana. So Jana would have an application level component. So think it's a Django app, but that Django app would have different user interface flavors. So there would be a typical web site, or you could call it a web application, uh, separate from the website, right? So the website would be more for business, but there will actually be a Jana web application that is a Vue.js application sitting in front of the Django middleware application. But that web app would also have many flavors. It would have an Android type interface, so that we would then deploy in Android devices. It would have an iOS type interface that would then deploy on iOS devices, right? So both of the Android and the iOS app would have a base app. So we're using Kotlin to do that. So we're using Kotlin to create the common code that Android and iOS applications will share. And then we'll fork off of that, and then we'll create the iOS and the Android specific user interfaces for Jana. Uh, but then there's feedback. This is really where our machine learning comes in, right? So all activities that are happening within Jana, from boot to networking to storage to computing to UI, all of these activities are logged using Kubernetes logs, and all of those logs are harvested into a machine learning pipeline that would then be modeled. And in those models, we basically, so imagine we would be able to model our boot layer, we're able to model our networking layer, we'll be able to model our storage layer, our compute layer, our UI layer. And that way, Jana is, so think of Jana as a self-aware platform. It would harvest data on itself. It will then model those data using TensorFlow, basically creating machine learning models out of the data. Those models will then be used to generate insights that will then be used to create new features within Jana. or new product. The idea is Jana is to be a money making machine. That the idea is Jana is a profit venture. As we go into this venture or this journey, the end goal is to make money and to educate and to learn and to have some fun doing some serious software engineering. Uh, so the main backbone that we need for our basically machine learning pipeline is a tool called Kubeflow. Kubeflow is basically how you create flow workflows for machine learning, right? But of course, it's called Kubeflow because it's done on Kubernetes, right? So the idea is Kubeflow gathers all the best tooling for processing data in the name of machine learning, right? So before Jana is deployed, Kubeflow is first deployed. And once Kubeflow is up and running, Jana will then be deployed. And then Jana will use Kubeflow to model itself and to learn itself and to become a self-aware platform that is learning and smart, basically an AI environment. Okay? So that's the overview of what we're trying to do here. So the operator is on GitHub. So if you want to check us out, so our website for the Jana operator is, so we're on the internet at www.jana is JANNAH.io, right? So check us out. But what you're looking at here on the website is a blueprint. Over time, this blueprint will be beefed up. The idea is every component you see here will turn into a full-blown feature within Jana. And then there will be subsequent videos, of course, where we showcase all of these pieces together over time in a journey-like way. We want to tell stories, but we want to tell stories about developing software using best practices, using the best techniques in industry as far as data science, as far as blockchain, as far as good old software development. Okay. Uh, our operator, though, is based on a tool called Charm. So what Charm lets you do, Charm let you create Kubernetes operators using the Python language, right? So right now in industry, there are three ways you can create operators. You can create Go-based operators that are written entirely in Go because most of Kubernetes is Go anyway. Uh, you can write operators using Ansible playbooks, where basically what you're essentially doing is you model your day-to-day management of your application using Ansible plays, and those plays are run when your operator is deployed in a cluster. So what we're kind of doing here is that's the middle way. We're using what's called a charm operator, which is basically a framework for building Kubernetes operators using Python. But because we had previously already written a lot of playbooks for deploying our component, we're basically taking our existing Ansible playbooks, we're wrapping them within we're wrapping them with a Python library that will then fire different plays based on what we want to deploy into a cluster. So we're using charm operators. If you want to get familiar with that, check them out. They're pretty cool. So the idea is you would have a client sitting on your local machine, your laptop here. That client is talking to clouds. You could have X, Y, Z clouds. You could have many clouds. And from your one computer, you can send commands to each one of those clouds to deploy various services and component. So that's the idea, right? So you would take the day-to-day activities that a human being will do, like a system admin will do to manage an application on the cloud. You would then encapsulate all of that day-to-day task into an automated script. And that automated script is basically what is called an operator. So an operator is just a fancy word for an app that manages another app. So in our case, we're building two different apps. We're building the Jana Accelerator, which is our main app. But to manage our accelerator app here, we would also create a Jana operator, which is basically, I don't want to get up every day and log into a cloud and manage the Jana platform myself manually with my hands. So what I'm doing, I'm automating what I would typically do on a day-to-day to manage Jana, encapsulate all of that into an operator that I would deploy into a Kubernetes cluster. And then that operator then would then issue commands onto that cluster, like you would see in this picture here. And those commands will be basically running, taking care of the app day to day. Okay. So let's go into actually deploying Jana. So this is the Jana code 3 here. One more time, we're on GitHub here. Check us out. So if you go to github.com/Jana.io, so it's JANNAHIO. So that's where we are on GitHub. So this is the actual Jana operator on GitHub here. Okay. It sits with 3 other code bases. So there's a front end app that would be the front end application for Jana. That's a Node, that's a Vue.js application. There's a middleware app that would basically supporting the front end application with all the data and compute power. And then middleware app also depends on a storage app that actually provides storage mechanism for keeping data over time. Okay, so let's actually get to the demo itself. Um, so what I'm going to do here, I'm going to first wipe out the existing Jana infrastructure that exists. So this is what we have already sitting into our cluster here. So if I do a kubectl get pods, okay? So this is from a previous deployment. So the beauty about using a tool like Molecule, it provides what we call an end-to-end deployment, right? So it would say, oh, you had previously deployed something here. Okay, so before I deploy something new, I'm first going to wipe out. So there will be a destroy phase where we clean out everything that was previously deployed, and then we will then recreate the entire infrastructure. So we will create a new cluster, and into that cluster, we will then deploy all our necessary components, and then deploy a fresh, brand new Jana environment. Okay, so what I'll do first, I'll say make clean. So here's our make file here. So there's a make file at the top of Jana, right? So I'm first going to do a make clean. So under this make clean target, what it does is first do a charm destroy. So it will destroy the previous infrastructure that was there. It will destroy the previous Python virtual environment that we have. And then I'll do a make charm converge. So what this will do, so let's take a look at the actual Ansible playbooks that would be fired for each one of these make commands. So here's our charm. Charms come with a file called charmcraft. So part of our deployment is we will build the operator container to on Ubuntu 22.04. So we'll build it to account so that it can run on AMD 64 architecture. We'll also build it so it can run on also ARM 64 architecture, right? So AMD 64 architecture, this is the traditional Intel-based chip, right? This is this ARM 64 architecture. These are the new Mac M1, M2 chips, right? So the idea is because we're using Macs to do day-to-day development, we want our operators to be able to deploy on a Mac M1 machine, but also to be able to deploy on Intel-based machines. So what this file does, what chamcraft.yaml does here, it says, okay, build the bundle the operator such that we can deploy it on AMD 64 architecture, or we can deploy it on ARM 64 architecture. So the idea is we build with this architecture and we run on this architecture. So we should be able to build on AMD architecture and run on AMD. We should be able to build on ARM architecture and run on ARM architecture. Okay, so the actual source code for the charm is here. So this is what a Python file is. So this Python file is an event-driven machine. what it does, it says, okay, what are my pieces for this operator, right? So what does this operator comprise of? So in this metadata file, you'll see, because we're starting this journey early in the journey. So right now there's two main pieces of these two containers we want to deploy as part of the core Jana, right? These are separate from the dependent services that Jana need, right? So Jana has a front end container that would be deployed. Jana has a middleware container that would be deployed. The front end container is a Vue.js application. The middleware container is a Django application. Uh, but in order to do that, we have Ansible playbooks here. These playbooks have roles. So here is our Jana end-to-end role. And we have a molecule infrastructure here where molecule will do a cleanup, it will do a destroy, it will do a create, and then it will prepare whatever was created. So, and in the converge stage, that's where we would actually deploy the dependencies, right? So let's take a look at the converge stage here. So here's our task. These are all the tasks that Ansible is about to run as part of our demo. Let's take a look at the converge, right? So if part of our converge, we would have to deploy Kubeflow. We would have to deploy Mattermost. We'd have to deploy Postgres. After those three pieces of software have been deployed, then we would come and actually deploy Jana itself, okay? So let's get started. So I'm gonna go into make file. So I'm gonna do a make clean. So I say make clean, make clean. What this will do, it will blow off this existing infrastructure we have. It will destroy all of this so that we can create brand new infrastructure that will then provision to run Jana and all of Jana's dependencies. Okay, so let's see, it's still cleaning. Let the make clean run, and then I'll do the subsequent command to actually deploy Jana's dependencies and Jana itself. So we're doing a make clean right now. Let that run. Let us see. Some tea. Okay, so we're doing a cleanup. This will wipe out any VMs that we have created previously and destroy any infrastructure we already have. That way we can make room for new infrastructure to be created. And within that new infrastructure, we will then deploy new services and our actual application and prepare for user interaction. Okay, so what it's doing now, it's deleting our virtual machine. So if I go and if I say multipass ls, okay, so it's destroyed. So we don't have any virtual machines now because it's just destroy it. We would then recreate it in the next step. Okay, so we've done a cleanup. So we've wiped out the previously established infrastructure. So the next command is, I'll say make churn converge. Okay, so what this will do, it will do an end-to-end deployment for Jana. It will create a virtual machine. Within that virtual machine, it will create a Kubernetes cluster. Within that Kubernetes cluster, it will deploy Kubeflow, right? So Kubeflow here, it will deploy Kubeflow that Jana needs. Jana needs all of these toolings you see here. So all of these pieces of software that Jana depends on will be deployed. And then once those are deployed, Jana itself will be deployed, and then we'll take a look at that, okay? So let's do a make converge. So part of what it does right now, it takes secrets, basically Docker passwords, GitHub passwords, all the sensitive passwords that we have. It encrypts them. It stocks them into an Ansible vault. So in our playbook, we don't have exposed, sensitive data within our logs, right? So that way we can run our end-to-end script and not have to worry about logs containing passwords or any such thing, right? So what it's doing now, it's creating a virtual machine, right? So if you go to multipass, I do ls, multipass ls, I see that it's starting to create this Jana operator virtual machine, and it's an Ubuntu 22.1 image. So let's go. It's still creating that machine. That machine is still getting started. Okay, so that machine is up and running now. It's been assigned an IP address, but it's running locally on my laptop here as part of this demo. But this cluster could be in a public cloud somewhere. It could be in a private cloud somewhere. As long as you have the Kubernetes kube file to that cluster, you should be able to point to it and run the operator against it, right? So, okay. So at this point, we've got a cluster, we've got an Ubuntu virtual machine up and running. We've mounted our local directory here. So this directory contains the code for the operator into our virtual machine. We're initializing our LXD environment. So actually, let's take a look at the actual play. So right now, we're running this play here. So this is part of our create play. So here's our task. We're in the create stage of our deployment. We're creating a multipass virtual machine. Specifically in that virtual machine, we're initializing our LXD environment. So this is all the way here. So we're at this step right now. Okay. So once LXD is initialized, we're installing our Chamcraft. So Chamcraft is how we basically craft our charms. And charms are basically fancy names for operators that are written in Python. So it's installing Chamcraft right now. Let that go on. Let me take a sip here. Okay, so what it's doing now, it's at this stage. It's completed this task here. So it's starting this other task. It's installing micro Kubernetes into our local virtual machine. Okay, so we need a Kubernetes cluster installed into our local virtual machine. And on that cluster, we would then deploy our Jana dependencies and Jana. Okay, so let it install Kubernetes. Okay, well, it's doing that. Let's take a look here. So if you're not familiar with Molecule, what Molecule is the way to say, I want to have my Kubernetes environment from scratch. So I'm going to create what I call scenarios. So each one of these is a scenario. So there's a cleanup scenario, there's a create scenario, there's a destroy scenario, there's a converge scenario, there's a prepare scenario, there's a verify scenario. So the first step is it does a cleanup, it destroys things, it creates brand new infrastructure. After it creates them, it prepares them. So what that basically means, it creates whatever user account or role that we need there. And then there's a convert stage where it actually does the actual deployment of the app. Okay, so we've done installing micro Kubernetes. So what we're doing here now, we're adding Ubuntu to the micro Kubernetes group. That way, Ubuntu as a user can talk to the Kubernetes instance. Okay. Okay, so we've completed that step. So we're, at this point, we're here in the process. So we're enabling necessary micro Kubernetes add-ons. Specifically, we're enabling the host path storage so we can use the hard drive on the local machine as it, basically for demo purposes to as our storage. We're also enabling DNS on the local Kubernetes cluster. That way we can actually talk to outside services. So let's let those add-ons get enabled. Okay, that's coming along. That's coming along. So let's go here. So at this point, we have a Kubernetes cluster here. We have an Ubuntu virtual machine here. It's been assigned this following IP addresses. So let's do this. Let's log in into that virtual machine. So I'm going to do multipath shell, Jana, charm, operator. Okay. So what I'm doing here, I say, okay, there's a virtual machine running locally on my laptop, uh, and I'm using multipass as basically my tool for managing local virtual machines, and then I use that same tool to shell into that operator VM. So if I do that, that should put me into the virtual machine. Oh, okay. So it's starting the virtual machine. So okay. So what this does, okay, so part of before we after we create the virtual machine and install Kubernetes, we restart the virtual machine. So what you're seeing here is that machine getting shut down and restarted again. Okay, so that once the machine is restarted, as part of our, so now we're in this prepare stage here. So we're done creating. Now what we're doing is we're preparing. So part of the prepare is we install Juju, right? And Juju is how we manage things on a cloud from a local computer, right? So think of Juju as a controller onto a Kubernetes environment, specifically for charms. It's a fancy kubectl. So Juju is here. If you want to learn about Juju and Juju operators, check them out. It's juju.is. That's the name of their website. Check them out. It's a pretty cool framework, basically writing Python-based operators. Okay, so it's installed Juju. It's checking to see what clouds do we have right now on that cluster. So when you do Juju clouds, it will show you the available clouds that have been created into that cluster. Okay, so you could see here we have a local LXD container running, but we also have a micro Kubernetes instant running on the cluster. So if I'm sitting here now on that machine, I should be able to say kubectl get pods, right? So right now, this is what our cluster look like. It's just the we've installed our controller. So this is the Jana controller. This is basically a local agent that sits on the cluster on behalf of Jana. So when Jana want to administer any command on that cluster, it will be through this controller that Jana will send commands, and that controller will then execute commands for us on that cluster. Let's go back here. So what we're doing now, we're bootstrapping uh, the controller and the model. So the way charm operators work is you have to create a model for your app. So a model is basically a namespace, right? So in the Kubernetes, when you deploy applications in Kubernetes, you deploy them under a namespace. So in the charm world, they say create a model. The model is basically a namespace, and all the components of your app will be deployed under that namespace, which is basically how they model applications, right? So Juju's model of applications in the Kubernetes is the namespace. So the namespace is the overarching umbrella, and under that namespace, you will deploy various services. So in the Juju world, they call that your model, the app model. So this is an operation that takes a little bit to run. So what we've done here, we're giving it 1600 seconds to run. So what we do, because it's running in this task is what you would call an asynchronous task in Ansible. So what it does, so I give it a maximum time to run of 1600 seconds. But then every 3 seconds, I do a pull to say, are you done running or are you still running? Then if it's running, then I wait for 3 more seconds. I check again to say, are you done? Until it's finished, then I continue to the next step. So all of this you've seen here is every 3 seconds we check to see when we add the model, basically we're adding a namespace that's attached to a controller, and then we check. So, okay, so that's completed. Okay. So we've bootstrap. Let's go here. Okay. So you could see here, we have a controller running. This is the Juju controller. This is our Juju model. Okay. So after that, we do a check status. So you could see here, we have the Juju model and our Juju controller running on this micro Kubernetes environment of version 3.0.3. And here's the timestamp where we used to deploy it. So after we deploy our controller and the model into the Kubernetes cluster, there's a few other things we need to install on the virtual machine itself. So this is just stuff I need for day-to-day development when I'm using virtual machines. So I need Python 3 installed on the virtual machine. I need pip3 installed on the virtual machine, and I need the Python virtual environment command also installed on the virtual machine. This is just stuff I use day to day, so I just install it there, just as part of my day to day debugging work, development work, not necessarily for production, but let that install. So it's executing this task right now. This is an Ansible task that's getting executed right now. It's doing an apt upgrade. Okay, so that's done. So what it's doing now, it's doing an apt install. It's installing Python 3 development flavor. It's installing pip3 and virtual env. So let that get installed, and then we'll continue on to the next step in this demo, which would be to basically pack the operator code base. So after we install this tooling, the next thing would be to say, okay, all of this code we have sitting here will be bundled into a file similar to this file here. So we're creating what's called a charm file. So what a charm file is, it takes your entire code base, it bundles it into a container. That container is then deployed into a cluster, a Kubernetes cluster. And once that container is deployed, events will be fired as soon as the container starts running. And when those events are ready, is what you see here. So there's a file here called. This is the Jana charm here, right? So it's subclassing the charm base. Right. So all of this is we're using charm base, right? Uh, we're subclassing charm base. We're creating a Jana charm. We're saying Once we see this container ready, we want to fire this routine, right? So it's a hook, right? It's to say, do listen for this event. If you see that the Jana front end container is started, run this hook. If you see that the Jana middleware container is ready, run this hook. And in this hook, we would call specific Ansible plays, to customize what happens when containers come up and running. So that's basically the core of an operator, right? Is to say, I have a way to see what's deployed, and I can fire events based on changes on my deployment. And basically, I'm using Python as a way to manage that whole process to say, when this container gets deployed, fire this event. When this container gets deployed, fire this event. When there's a config change, fire this event. And those events can be specific things, right? So in my case, what I'm doing here, I'm adding custom layers to my containers. So what chant operators let you do, they let you deploy a typical Docker, image into a cluster. And once the image is up and running, you can dynamically add new layers to that container at runtime. And those layers, once they get added, a new plan, they get what's called a replan. So basically, this is basically, mixing up all of the layers to create a new image, right? And then the container will be restarted. That way, you can have a container in production, and you can still add new layers to that container at runtime using an event-driven platform. That's basically what the charm operator is. It's a way for us to say, you can deploy a container, fine. But once that container is up and running, that's not the end. We can also add new layers to that container and create new plans, and then restart the container with that new layer enabled. And you could get very fancy at how many layers you want to add to a container. Okay, so right now we're still packing, so we're still here. So let's go back to our prepare stage. So we were here. We're now end to end. We're in our molecule end to end scenarios. We're preparing things. So we're in here. We're doing an exact prepare. We're packing the operator code into a file that looks like this file here, a charm file that we would then deploy into our Kubernetes cluster. So let's take a look at our Kubernetes cluster right now. So right now it still looks like this. Okay, these are just the basic services that the Kubernetes cluster came with. Okay, these are the controller and the model we just added to that cluster. And then we would create a container image that's basically the operator. We then deploy that container image into our cluster. That operator then will then say, okay, which one of my services do I need up and running? And the way it knows, it says, okay, this is my metadata file. I have this service, and I have this service, and I have this service, and they're all running on Ubuntu images right now. And we can change all of this later on, of course. Okay, so we're still packing the operator, so that takes a little bit of time. Let's be patient with it. Let's let it pack. Let me take a sip here. So let's take a look at the operator while that's happening. So if you notice this virtual machine, okay, I gave it 8 cores. These are the 8 CPUs that I've assigned to it. I gave it 18 gigs of RAM, okay, and I also gave it 100 gigs of hard drive space, and that's enough to install Kubernetes. Uh, it's enough to install a whole bunch of services into that Kubernetes cluster. So it's it's pretty beefed up. For local deployment, of course. So as you can see here, this is basically all the CPU. If you look at the top here, this is all the CPUs that are running and how much load is on the CPU. This is giving you the load average over this for all the CPUs. This is telling you how much memory we're using. So of course we're not that heavy yet because it's very early in the deployment. But as more services are deployed, you will see more memory getting used here. You'll see the CPUs get a little bit more busier. Hopefully, we'll never get into swap. Okay. Um, so we're still packing while that's happening. Usually, while that's happening, I'll just keep an eye on the processes here just to see who's doing what, how much load is being spread around on each one of the CPUs. One more time, we have 8 CPUs here, 0 through 7. We have 8 gigs of RAM. We're very early in our deployment right now. The code for the operator is getting packed by the Churncraft tool. Churncraft is how you pack. It's basically how you craft the operator. You take all of the code, you bundle into a zip file. That zip file get put into a container. That container get pushed into a Kubernetes environment, and that container starts and start deploying all your services based on your charm file. This is the charm file. Let me pull up our charm file. All right, based on your charm file. So in our charm file, like I said one more time, we have 2 services that we've defined in our charm file. Our main 2 services for now, they are our front end application, which is the Vue.js application. So there'll be our Vue.js application will be deployed in a container. Our middleware application will be deployed in a container as well. And they're all both using an Ubuntu image for now. Um, you know, obviously all this can change over time, but for now, as far as like getting the project up and running, that's where we are. So let's let it pack. It's still packing. Let me take a sip of my tea here real quick. Let's be patient with it. Packing takes a minute. Let it pack. We're here in our process right now. Let it pack, let it pack, let it pack. So if anybody don't know about operators are a pretty cool idea in the Kubernetes world. Nobody wants to get up and log into a cloud by hand, manage your things by clicking and pointing in a cloud. There's no way you can scale that over time. So the idea is you take your day-to-day activities, you write a script or an Ansible playbook, and that could be in Python, it could be in Go, it could be an Ansible playbook, and then you set up some kind of an event trigger way, such that you would know what task to trigger, what task to fire based on what's happening, and you set up these rules. So in our case, we have just basic rules to say, you know, once our containers are deployed, we're going to run this Python functions here, and these Python functions could be anything. So in my case, I'm adding new layers to my containers. because I like to deploy vanilla containers. And once the containers are deployed, and then I can start to basically add complexity to them as part of my operator. So the idea is I'm not deploying full-blown built images. I built I built simple images. I deploy them, and once they're deployed, I start adding layers to them to get them to the place I want. And that's basically what the operator is doing. Right? It's a fancy way to have very thin, images. But when those images are deployed, you could biff them up with layers upon layers of complexity, depending on your infrastructure. So let's be patient while this is running. Let me take a look here again. So we're still running. Okay, so we're installing a few things. So pip is running. Okay, so chamcraft pack command is running. Okay. Okay, it's still running. The packing is still happening. So just keep an eye on the processes right here. This one is very busy. Okay. So at least they're churning along. They're doing work. So it's moving along. Expand this a little bit. We're still packing. Okay. So still here. Pack operator. I give it 9800 seconds to run, and I check on it every 15 seconds. Because what I noticed the other day, so if I'm just typically running the end-to-end deployment, when I go to pack the operator, it takes a little bit, but not that much. But if I'm streaming, for some reason, when I'm streaming on the same laptop where I'm actually doing the packing, because of the competing for resources, that usually will take a little bit longer. So what I had to do to get away from this getting timed out is basically I bumped this up to some ridiculous number like 9800 seconds, just to be safe, just to make sure that it actually eventually runs and not time out. Okay, so that's why I put this 9800 seconds here, and I pull it every 15 seconds to see if it's completed or not. But obviously, it's still running. So typically, the way I get around that wait time is I come over here and I say, okay, what does the CPUs look like? Okay, they're all busy. Some of them it's 100% busy. Okay, and I say, okay, what is my load average? Okay, so we're not heavily loaded yet because we're still packing the operator. We have not actually deployed the services yet, but once they start to get deployed, you start to see the load average increases because there's more containers being deployed and more services are up and coming and running. So it takes a bit of time to get there. So let's just be patient. So we've consumed 1.65 gram, 1.65 uh, gigs of RAM. So that leaves us 17 gigs unused. So we're very early at this point. So we're not taking a lot of memory. A lot of the work that's being done right now is just crunching data to pack the code into a container. So that's why we see most of the work is happening on the CPU level. This is still running. Let's be patient with it. Well, that's happening. Let's go over here. Take a look at Kubeflow. So what we're trying to accomplish basically is this pipeline here, right? So we want to be able to run pipelines like this, and that's basically why we're deploying Kubeflow. The idea is uh, we'll be able to do data science experiment where we identify problems, we collect data. Uh, you know, in my case, what I want to do, I want to collect logs from all my services. So the idea is each one of these components here from boot, networking, storage, compute, user interface, all of this would be logged. All of these containers will be producing logs. Those logs will be then be pulled into a Kubernetes framework like this that is basically called Kubeflow. Uh, those logs will choose, we'll choose appropriate machine learning models to model those logs. We use tools like Jupyter notebooks that, day-to-day data science, looking at the logs, manipulating them, learning the best ways to model them, and then coming up with hyperparameters and, fine-tuning our models. Uh, and then basically get into a production phase where we have models that we can use in production, and over time those models also get improved and better. So it's an endless loop of learning and improvement, right? So the idea is we should be able to generate logs. Oop, oop, we're done packing. Okay, sweet. The packing is done. Okay, so what we're doing now, we're actually deploying Kubeflow itself, right? So let's go here. So we're done with this stage. Awesome. um, So now we're actually in the converge stage. So if you look over here, this is our converge stage. So we're deploying our dependencies. So our main dependency is the Kubeflow, right? So what we first do, we create a model for Kubeflow. We come here, we deploy Kubeflow. So that's what's happening now. So if I go now here, let me get out of this screen. Um, if I do kubectl will get pods, kubectl get pods. Okay, soon I should. Okay, so you could see here Kubeflow. There's a namespace for Kubeflow now. So soon we should start to see those services coming up, right? So Kubeflow is still getting deployed. Okay, as you can see here, services are starting to come up, right? As Kubeflow is getting deployed, you could see here, services are getting initialized, right? So now there's a few more services here. If I do that and I say I want to count my services. Okay, so right now we have 15 services up and running. So if I go over here and I say multipass, ls, and I connect into that shell, Jana, term, operator. Okay, now if I do htop, okay, things are getting a little bit busy now. Okay, if you can see, all 8 CPUs are getting more load. Uh, Now we're up to 1.88 gigs of RAM that we're using, almost up to 2 gigs of RAM is getting used. And as more services are getting deployed, the load on the CPUs get higher, more memory is being used. The cluster, the VM is getting more busy. So right now we have up to 15 services deployed. 19 services are getting deployed right now. So if you want to see what those 19 services look like, okay. So that Katib DB operator is getting initiated. So some of the services are already running. Some of them are getting initiated right now. Some of them are pending, and they'll all be coming up one by one. So right now we've done deployed Kubeflow. So at this point, we're deploying MetaMost. So let that get deployed, and then we'll deploy Postgres. So now Postgres is getting deployed here. Mattermost use Postgres for storage. So what we will do here, we'll integrate Mattermost with Postgres. And here too, we give that 1600 seconds to run. That's just a high number I put there just to be safe. Okay, so now we're actually deploying Jana itself. So this is getting run right now. Okay, so right now Jana itself getting deployed. Now it's gonna do a kubectl get pod at the end just to see. Okay, so we're done with our deployment. Okay, so we just went from top to bottom. Well, we just ran the make converge. It ran all the way through. It's deployed all the Jana dependencies and Jana itself. If we come over here, we could see how that looks right now. Okay, let me just expand this a little bit. So you could see some of the services are up and running already. Some of the services are getting initialized. Some of the containers are getting initialized. Okay, so this pod is getting initialized. So it takes a little bit of time for all of the services to come up and running, but you get the idea. So this is basically how we deploy Jana using a term-based operator, which is basically an operator written in Python with a extension with extended capabilities using Ansible, right? So what I've done, I have Ansible playbooks that deploy services, and on top of that Ansible playbook, I will Python event machine that will then fire off different Ansible roles based on containers that are up and available running. Right, so that's basically the guts of the operator is to say, I have playbooks that I run, and I have events that I listen for to know which playbook to run. And when I see a such specific event happen, I run a specific play, right? So that's the idea. So we're done with that part. So what we have to do now is just wait for services to come up and running, just like you would do it, you would on any other Kubernetes project. So the idea is once you do a deployment, containers have to get deployed, services have to come up and running. So that takes a little bit of time, but if I do kubectl get pods, you see what's running now. Okay, so if I want to check how many services are being deployed right now, okay, so for now 33 services have been deployed. So they're coming up. In all, there should be about 86 services that I expect to be up and running. So that takes a little bit of time to run. So we could end the demo for now. You get the idea. Uh, the point is we have Ansible playbooks where we have playbooks to deploy component of our infrastructure. Those playbooks are wrapped in a Python script that is event driven. Based on events that are getting fired, specific Ansible playbooks will be deployed, and that's what we call our Jana operator. So what you're seeing here now is all of the components of Kubeflow. So what you're looking at here, these components, all of these components, they're getting deployed locally on my laptop here on a local Kubernetes cluster. It takes them a minute to come up and running, so be patient with them. But the idea is you can have Ansible playbooks, you can wrap those playbooks in a event-driven Python script, and whatever events that are fired, you could have corresponding playbooks that are run as a reaction to that event, and you could use that as a model to basically manage a day-to-day Kubernetes application deployment. Right? That's basically the idea. So let's just give this a little bit of time, just to have a few more services up and running. I'll end the demo shortly, but you get the idea. So right now, I'm gonna do kubectl get minus w parts. Okay, that way we can dynamically see what's coming up. We can see what's up and running, what's getting initiated. Okay, let me take a little sip real quick. Okay, let's count. Let's take a count of how many things have been deployed so far. Okay, so far we went from 33 to 43 services being deployed. This should go all the way up to 86. Okay. Okay, some of our services are running, some of them are getting initiated, some of them are pending. It takes about an hour or so, maybe like 40 minutes really, for all 86 services to be up and fully running. Um, in subsequent videos, we'll delve deeper, right? We'll then start to say, okay, this is what the Jupyter service look like. This is what the Jana IO front end look like. We'll take a look at various components here. We'll take a look at these various components here in the subsequent videos. So this will be our, there'll be a whole bunch of videos that we're going to be putting out to basically showcase what we're doing at Jana as far as day-to-day, week-by-week deployment, week-by-week application management. That way you get a sense of what software engineering feels like, So what we basically want to do is we want to create a show, a television show, where, think of it like a cooking show or any other show where people are, building things, pimp my car, any one of this kind of show, basically. In our case, we're developing software, right? So we wanna make the day-to-day development of software available to the public as a television series. That's basically what this whole point is. So this video is just a rough cut, just to get a sense of like what's happening, just to put the word out. So if you want to get involved, check us out. Hit me up. My name is Usman. You could email me at usman@jalolab.com. Or you could get me also at usman.jalloh, that's OSMAN .jalloh@gmail.com. You could also reach me there. So one more time, two emails you can reach me at: Usman, OSMAN @jallohlab, JALLOHLAB.com. You can get me at that email. Send me your resume. Tell me what you want to do as far as like, are you a UI guy? Are you a backend guy? Do you like infrastructure? Do you like DevOps? Do you like machine learning? Or do you like data science? We'll find a place for you. The idea is whatever part of the stack of software development you're comfortable with, you want to join something exciting and fun, join us. We'll find a place for you. You can contribute somehow. Do you want to fund the project? If you have some cool product idea you want to build, we're essentially building a shop for building products. So if you think you have something sweet to build, let us hear about it. You never know. We can find funding. We can make it happen. You never know. So that's the idea. But basically, that's where we are. I'm gonna end this demo for now, where you get the idea. Jana is a shop. We build software at Jana. Specifically, our software are targeted for cloud deployment, but cloud doesn't necessarily mean outside cloud. It could be a private cloud in your data center. It could be a private cloud in your house. As long as you have, you know, desktops or laptops that are juicy enough to run, Kubernetes environments. You should be able to run, what you're looking at here is a cloud locally on my laptop. Uh, if you have a nice juicy laptop, you should be able to, to deploy Kubernetes and deploy apps on it. Um, if you have cool ideas you want to do as far as data science, as far as machine learning, reach out. One more time, you can get me at osman.jalloh@gmail.com. You can check us our webpage here. If you go to Jana.io, if you go down all the way to Jana.io, you could find me here on my Twitter. That's my Twitter account here. Reach out to us. You never know. We might do some cool projects together. So yeah, get involved. Let us know what's going on. But I'll end this demo for now. But for one more time, just to see our services that are coming up. Okay, so they all they're coming together. They're coming. So let's see how many of them we have right now. We have okay, so we have 54 services deployed so far. This should go all the way up to 86. I will end the demo right now. Thank you very much. We look forward to hearing from you. We want to do some cool machine learning. We want to do some cool data science. We want to do some cool blockchain. We need funding. We need experienced developers. We need new developers at every skill level. We're willing to do some mentoring. We're willing to do some evangelizing. Join us. This could be very, very cool. Yes, let's have some fun. I thank you guys.